So to kind of wrap up the discussion of this particular example, there's a bunch of other cool things here that I won't really have time to go through in detail. There's a file called prime utils, which has some methods to check if a number is prime using this clever technique of passing in a function, which could be a memoizer or not. There's the isPrime computation, which is deliberately meant to be rather slow, but just to burn CPU time. There's some cool methods to print primes. This is kind of fun. So what we do here is we are going to take the sorted map that we get. I'll show you how you can generate the sorted map in a second. And if you want to print the primes, if the map is sorted, then the values that are in the beginning of the map are going to be 0 because those are the prime numbers. And so what we're going to do is we're going to take the sorted map and we're going to take the elements from the map while the values are 0. And so the keys in this case are going to be the result of checking if something is prime, and the values will be the number itself, the prime candidate. So we're going to keep taking those things, and then we're going to go ahead and just extract out the key. So in this particular case, we're actually sorting this by value, it turns out. The values are going to be 0 if they're prime. The keys will be the numbers themselves. And then we collect those things into a list and we block until the processing is done. And when we're done, we just go ahead and print out the list of primes, which is pretty cool. You can also see how to print non-primes. So to print non-primes, we take a sorted map, and instead of using take while, which we'd used here, instead we're going to use skip while. So while the values in the map are 0, we're going to skip over them. We're going to skip over all the prime numbers. And then when we're done, we're just going to end up with the rest of the flux being essentially the non-prime numbers, which we're going to collect into a list and print them. Now, the other thing I want to show you is how we're going to actually sort these values. And if we go over here and we look at Reactive Utils, there's a method here, helper method called sort map. So the idea here is to sort the map, and we're going to pass in a comparator. So we're going to use the comparator to sort the map. And if we go over here, I think, and we take a look for sort map, you'll see what we do is we say Reactive Utils sort map, we pass in the map, and we pass in the comparator, which is comparing by value. So we're going to sort by the values, which will be either 0 if they're prime or greater than 0 if they're non-prime. That'll be the smallest factors. So if we go back over to Reactive Utils again, we're getting in the map and the comparator, and we go through every element in the elements in the map in its entry set, as it's called. We sort by the comparator, which will sort by the value in this case. And then we do some really clever technique here where we're going to collect, and we're going to collect into a map, a new map, and it's going to have the key is the key and the value is the value. And we're going to use a linked hash map so that everything will be able to be iterated through in the right order that we put it into the map. And that's how we're going to go ahead and create a sorted map. So it's a very clever algorithm for sorting a map. I'm sure there are other ways to do it as well, but this is the one that I tend to like.